Hello students, let us start class 10th mathematics. The first chapter in class 10th mathematics is real numbers. Let us recall, in class 9th we had studied that real numbers are the combination of rational numbers and irrational numbers. Further recall that in rational numbers we had fractions, integers, whole numbers and natural numbers. The reason why these fractions, integers, whole numbers and natural numbers are considered under rational numbers is they can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. The fractions, for example, if you consider 3 by 5, it is there in the form of p by q. Further, if you take integers, say for example minus 5, this minus 5 can be written as minus pi by 1. Now it is in the form of p by q, where p and q are integers and q is non-zero. Same way, this set of whole numbers and natural numbers can also be written in this p by q form, where p and q are integers and q is not equal to 0. Further recall, we had expressed the numbers in decimal form. Some of the numbers, they are terminating decimal, or some of the numbers are non-terminating but recurring decimal. For example, if you consider a number say 1 by 2, this when expressed in decimal form will be 0.5, a terminating decimal. If you consider a number say 10 by 3, when expressed in decimal form it will be 3.333, it continues, or it can be written as 3.3 bar. This type of decimal is non-terminating but recurring decimal. Some of the numbers, when expressed in decimal form, they will neither be terminating decimal nor be recurring decimal. Such type of numbers are irrational numbers. For example, root 2, root 3, 2 plus root 2, 0.10, 100, 1000, so on. They are irrational numbers. The combination of these rational numbers and the irrational numbers together, they form the set of real numbers. If you look at the Venn diagram for real numbers, it can be shown like this. The smaller circle inside in yellow color is set of natural numbers. They are contained under the set of whole numbers, which contains 0 and the counting numbers. These whole numbers are the numbers from 0 onwards. They are under the set of integers. These integers can be expressed in p by q form, so they are rational numbers. The set of rational numbers here is represented using the letter q. Apart from these rational numbers, we have irrational numbers, which are represented using this blue color. The combination of this irrational numbers and the rational number together, they form the set of real numbers. Now look at the number line. On the number line, we have integers which are at constant distance from each other. The positive numbers 1, 2, 3 and so on, they are the positive integers. The numbers -1, -2 and so on, they are the negative integers. 0 is neither negative nor positive. Not only these, we have 1/2, -1/2, they are rational numbers. √2, √3, 3.101001000 so on, they are irrational numbers. So these combination of rational numbers and irrational numbers, they all can be expressed on a number line, so the number line is called real line. In class 10th, we are restricted to only positive integers. There are two important properties which are to be studied in class 10th. They are, the first one, Euclids Division algorithm, and the second one, fundamental theorem of arithmetic. Using Euclid Division algorithm, we have a method to find highest common factor of two positive integers. Using fundamental theorem of arithmetic, we have a method to find highest common factor and the least common multiple. We also have a method to find whether the given rational number is a terminating or non-terminating but recurring decimal. Let us begin with Euclid's division algorithm. This Euclid's division algorithm is also called as Euclid's division lemma. Lemma is a proven statement used for proving other statements. The statement of Euclid's division algorithm is, for given positive integers a and b, there exist unique integers q and r such that they satisfy the given equation a is equal to bq plus r, where 0 less than or equal to r less than b. This statement looks difficult. Let me make it more simple by considering an example. Let me take two positive integers, say a is equal to 17 and b is equal to 5. For these two positive integers, there exist, this is a symbol for there exist other two numbers, say q and r, such that they can be expressed as a is equal to bq plus r. Let me divide 17 by 5. 17 goes with 5 3 times and it leaves the remainder 2. This division can be expressed as 17 equal to 5 multiplied to 3 plus 2. Here the remainder is 2. It is very clear that this is less than the given divisor 5. In some cases, like when 15 is divided by 5, 15 goes with 5 3 times, leaving no remainder. In this case, the value of remainder is 0. So is the condition. Remainder is either equal to 0 or greater than 0, but always less than the divisor. Let us find the highest common factor of two positive integers using Euclid's division algorithm. Before we find highest common factor, let us understand the meaning of highest common factor. The highest common factor of the two numbers a and b is the highest positive integer that divides both A and B. We find highest common factor of two positive integers using these three steps. Let us take an example and understand how to find highest common factor of these numbers. Let us find highest common factor of 910 and 42. Step 1. Apply Euclids Division lemma to C and D so that we find two whole numbers Q and R such that they satisfy C is equal to dq plus R, where 0 less than or equal to R less than D. Here the value of C to be 910 and the value of D to be 42. This C can be expressed as dq plus R. So 910, I'll express it as 42 multiplied to 21 plus 28. Look at the second step. If R is equal to 0, then D is the highest common factor. In this case, the value of R is not equal to 0. So we have to further continue and express 42 as 28 into 1 plus 14. In this case also, the value of remainder is not 0. So we have to continue further and express 28 as 14 times 2 plus 0. Here we get the value of remainder as 0. Value of remainder is 0 for divisor as 14. So the highest common factor is 14. Suppose if somebody asks you what is the highest common factor of 28 and 14, you will be able to say that it is 14 because in the previous step we have observed that remainder was 0. Now if they ask you what is the highest common factor of 42 and 28, will it be 14? Let us check this. Let us take this step. 42 equal to 28 into 1 plus 14. Now we need to find out the largest number which will be dividing both these 42 and 28. Let me consider this part, the right hand side part. In this right hand side, if I divide by 14, 14 two times is 28, 14 one time is 14. So the right hand side completely gets divided by 14. So left hand side also will be divided by 14. Therefore the highest common factor is 14. Will this be applicable for our question 910 and 42? Look at this, 42 into 21 plus 28. The highest number which divides this 42 is 14, and 28 also it is 14. Therefore the highest common factor is 14. Let us understand by taking one more example. Find highest common factor of 4620 and 2964. Now I have taken slightly larger number. In this case C is 4620 and D is 2964. This 4620 is larger than 2964. So I will express 4620 as 2964 into 1 plus 1656. Since the remainder is non-zero, this 2964 should be now expressed in terms of 1656. Yes, it is 1 time plus 1308. Further, remainder is not 0, so 1656 should be expressed as 1308 into 1 plus remainder is 348. Now 1308 can now be expressed as 348 into 3 plus 264. Now 348 can be expressed as 264 into 1 plus 84. Now this 264 can be expressed as 84 multiplied to 3 times plus 12. Now 84 can be written as 12 multiplied to 7 times plus 0. At this step, remainder is 0, so the divisor is the highest common factor. Therefore, the highest common factor is 12. There is some logic which is to be understood to understand further question. Now look at these numbers. I have taken the numbers from 1 to 100. Now if I want to find out the multiple of 2 format, all these numbers which can be written as the multiple of 2 format. If I take 2 as the number, the next number is 2 plus 1. Next to that number is multiple of 2. So all the numbers are like 2m or 2m plus 1. Suppose if you take 6 as the number, this 6 can be written as 2 multiplied to 3. It's a multiple of 2. Suppose if you consider 9 as the number, it can be written as 2 multiplied to 4 plus 1, which is a multiple of 2 plus 1. So all the numbers are either in 2m format or 2m plus 1 format. Same logic can be used by taking the 3-factor format. The numbers will be like 3q or 3q plus 1 or 3q plus 2. The same logic can be applied by taking the number 6 format. The number will be in the format of multiple of 6 or 6 plus 6n plus 1, 1 plus multiple of 6 or 2 plus multiple of 6 or 3 plus multiple of 6 or 4 plus multiple of 6 or 5 plus multiple of 6. The same logic can be used for all the numbers here. Let us take the first question. A positive integer is in the form of 3q plus 1, q being a natural number. Can you write its square in any form other than 3m plus 1, that is 3m or 3m plus 2 for some integer m? Let x be that number which is in 3q plus 1 form, where q is a natural number. Let me square this. X square will be 3q plus 1 whole square. If we expand this, we get 9q square plus 6q plus 1. This can be written as 3 multiplied to 3q square plus 2q added to 1. Now this is like 3m plus 1, where the value of m is 3q square plus 2q. For some integer m, for some positive integer m. Therefore, all the square of the number is in the form of 3m plus 1, not in the form of 3m or 3m plus 2. Therefore, the answer is no. Here is a reason for that. Now let us take the second question. Find the highest common factor of first one 135 and 225, second one 196 and 38220, and the third one 867 and 225. Out of these three questions, let me solve one of them. The rest two you can try. Let me take this second question, 196 and 38220. Out of this, 38220 is a larger number. I'll express this 38220 as 196 multiplied to a number plus remainder. For that, I need to divide. 196 one time is 196. And we will be left with 186. Let's take to carry here. 9 times is 1764. Let's subtract. We get 98. Let's take this 0 forward. 5 times is exactly 980. Here we get remainder as 0. So 38220 can be written as 196 into 195 plus 0. Therefore, the highest common factor of 196 and 38220 is 196. Let us solve next question. Find the largest number which divides 615 and 963, leaving remainder 6 in each case. The required number will be the highest common factor of the numbers minus 6, which is equal to 609, and 963 minus 6, which is equal to 957. Now 957 is a larger number than 609. Now I'll express 957 as 609 into 1 plus 348. Now the remainder is not 0, so I will express 609 as 348 into 1 plus 261. In this case also, the remainder is not 0, so further I have to express 348 as 261 multiplied to 1 plus 87. Now 261 should be written as 87 multiplied to 3 plus 0. In this step we get remainder 0, where the divisor is 87. Therefore the highest common factor is 87. Let us solve one more question. Find the greatest number that divides 445, 572 and 699, leaving the remainders 4, 5 and 6 respectively. Like the previous question, the required number is highest common factor of 445 minus 4, because the first remainder is 4, 572 minus 5, which is equal to 567, and 699 minus 6, which is equal to 693. Here we have three different numbers for which highest common factor to be found. So first let us find highest common factor of the first two numbers 441 and 567. Using the algorithm, this 567 can be expressed as 441 into 1 plus 126. Now further 441 can be written as 126 multiplied to 3 times plus 63. 126 is 63 2 times plus 0. Here we get the highest common factor. Now we need to find the highest common factor of 63 and 693. This 693 is a larger number, should be written as 63 multiplied to 11 times plus 0. Therefore the highest common factor is 63.